Welcome everybody. We'll give it a few seconds for folks to get dialed on and get started. Okay, let's go ahead and get started. Welcome everybody. My name is Jeremiah Tussey. I'm the Alliance Manager in Product Marketing at Microchip. And here I'm representing the SCSI Trade Association as the Vice President. And our topic is tiered storage deployments with 24 gig SAS. This presentation is meant to remind integrators about SAS being the most widely used in storage technology in traditional modern data centers. And you know, most of you already know where SAS is commonly used, but there are some places that might surprise you where the SAS technology is specified and deployed. And so, you know, serial attached SCSI, also known as SAS, is the only storage interface that embraces both high performance, high reliability, as well as providing native compatibility with low cost per gigabyte SATA drives. So the combination of the SAS and SATA infrastructure on a SAS topology allows for a span of a variety of storage environments, including tiered storage solutions, which is part of our topic here today. Large-scale data infrastructures utilize tens of thousands of hard drives and SSDs in their deployments, and compounded by recent capacity demand via storage-based cryptocurrency, work from home, other activities. This is ever-increasing area. A couple of housekeeping items. There is a box or button to submit questions on the right side, so please feel free to submit your questions as they come to mind, and we'll work to answer those questions at the end for Q&A. Otherwise, if we don't get to all the questions, or for any of the questions, we will be producing a blog post after this event to answer all the questions that are submitted. The slides will be available for download as PDF a few minutes after the webcast concludes. And for those who are not familiar with the SCSI Trade Association, please visit SCSI TA, that's SCSITA.org, for more information or to inquire about joining our organization, getting on a newsletter, any number of activities there. So just a high-level agenda of what we'll be discussing here today in this webinar. The enterprise storage market, it has some interesting data. I'll be doing an update on what the scope of the market looks like and where SAS and SATA fits into the ecosystem and into the topologies that are being deployed. And then I'll give an overview of the 24 gig SAS enhancements that are part of the latest standards, just to give some background in the areas that 24 gig SAS is tuned for. And then we'll talk about the storage tiers, the main topic for today, and the applications for 24 gig SAS and storage that's attached to 24 gig SAS in different types of tiering models. And I'll conclude with some data center applications and examples for context and referencing of the tiering model, and then summarize with some key takeaways. And we'll go into any Q&A that comes up at the end. Okay, so the worldwide enterprise storage capacity shipments from 2015 to 2025, as shown here in this graph, as forecasted by IDC using their worldwide hard disk drive forecast, solid state drive forecast from May 2021, shows increasing growth in a couple of different areas. So what I want to highlight here is we've consolidated this view to show the SAS, SATA, hard drives, and SSDs in the portion that's shown in blue, and we're also showing the PCIe SSD portion in green. So both growing and important markets. But the focus here is to show the vast deployment of enterprise storage capacity based on SAS infrastructure, including SAS and SATA hard drives and SSDs. So this is also growing in parallel to PCIe NVMe storage, which is making a lot of waves in the industry. But from an overall perspective, the growth just continues in either market. And with the scale of NAND flash capacity that's deployed today, unfortunately, there's nowhere near the hard drive capacity available in flash NAND technology to supplant or replace it directly today. So there's always going to be this need for hard drive capacity, at least in the foreseeable future as forecasted here. And it's a pretty vast amount. 2,000 exabytes by 2025 for the SAS SATA expected portion at this time it's pretty impressive. But with all of the dynamics of data proliferation in the world today, it's understood to most degrees, and we'll give some context with some examples as we come up to the next slides. From a background on where 24 gig SAS stems from, here's the specification and enhancements timeline. So working your way up, kind of building upon each other. We have 3 different main levels. The physical layer shown at the bottom is the foundation of the SAS infrastructure for providing the physical interconnect. Just going a couple of generations back with SAS 2, SAS 2.1, where we defined 6 gig SAS, different ways to manage cables and implement those into the topology, to SAS 3, which was the last generation based on 12 gigabit second link rate. Sorry, we had a little hiccup there. The SAS 3 interface is based on equalization, ways to dynamically enhance the data connection at the physical layer, and then going forward into the current generation of SAS 4, where we've gone to a 22.5 gigabaud data rate with implemented 20-bit for error correction for increased signal integrity and capability of maintaining the data reaches that are defined with the cable links in the specification, and supporting new cable and connector definitions as well. Building upon that, we have the SAS protocol layer, SPL2, SPL3, supported SAS 3, and the transmitter training optical cables were defined there with persistent connections and other options for increasing the resiliency of the SAS interface. Going into the current generations of SPL4 and SPL5, where we're defining more specific SAS packets and the active PHY transmitter adjustment, which allows for dynamic tuning when you have different voltages and temperatures that might be impacting the signal integrity. So future-looking retimers, enhanced wide ports, interleaving are different technologies too that we're looking to add on to this current generation. And then on top of that, we have the SCSI command layer. So this is where we're defining the different standards for the ZBC, SMR support. We have multi-actuator drives that are being adopted. We have zoning capabilities, lots of different configurations for zoning. That this is where those are all defined, and that makes for the infrastructure at the host level to support the devices on the back end. So this is the evolution of the enhancements and the specifications over time. So as for the main topic for today's conversation, tiering. So the storage tiering comes in 3 different flavors: a hot tier, a warm tier, and a cold tier that we're focused on with the SAS deployments. So here we have IT infrastructure that has different requirements depending on the applications. They have different levels of cost of ownership. They want to have different ways to manage the systems and power. And there's different deployment models for RAID. If you have a configuration that needs more resiliency, you deploy RAID 5, RAID 0, 10, 1, different flavors of the typical RAID that the industry knows, and focus on the overall device lifetime, so endurance, and how do you maintain your data over the long term. So here at the hot tier level, you have a focus on SSD deployments. In this example, we have SAS or SATA SSDs. You have a server that is going to be based on your most performant SSDs, whether it's SAS or SATA. SAS will be the highest performant with the highest price associated with it, but SATA SSDs might be the balance between price and performance that some implementers might require. And the focus for the applications here will be financial trading, gaming, virtual reality, business transactions, artificial intelligence, and machine learning. Those are some of the tiers of applications that require more performance. So your storage requirements are focused on the IOPS, the I/O operations per second. Where 24 gig SAS benefits this tier is supporting the high performance with the SAS, or a more of a middle tier performance using SATA SSD, depending on the configuration. So optimizing based on your cost performance point required. So the data management has evolved over the years. So we got to acknowledge that the storage environment is evolving as well with newer technologies. But rotating media is still the most cost effective for data storage. So that'll come into play in the next levels of the tiers. So here we have the warm tier. The warm tier is where you'll have a mixture of SSDs and hard drives. You'll have your servers that may be based by SSDs to have a caching layer that implements with the hard drives that are going to be typically nearline hard drives, whether those are SAS or SATA. Those hard drives tend to be a focus for a balance between performance and capacity and cost, depending on the needs. But the applications you're focused on are not necessarily the highest performant, but where you need a balance of performance and longevity of storage of the data. So Internet of Things, where you're storing data that's being captured by devices. Business analytics, where you need to analyze the data, where whether you're capturing as fast as you can in an SSD hot tier, you need to have it stored somewhere and have an intermediate processing and analyzing of the data. And then social media, which we'll have an example a little bit later, as well as cryptocurrency, where you have a balance of a need for instant communication versus storing versus showing a feed. Cryptocurrency, storing data to fit the model of that deployment. So overall, the storage requirements here are focused on scalability, so you can scale out as your requirements require more capacity or more performance. If you need to scale in a all-flash array into the mix, or if you need more capacity with a nearline hard drive based JBOD, you have the flexibility here to do a balance of capacity, performance, and cost. And then the capability of the SAS infrastructure allows for redundancy as well. And this is where you'll see different implementations requiring RAID and dual failover capabilities that allow for one side to be up versus another side that might be interrupted by one thing or another. So there's the redundancy factor built into the SAS standard. So where 24 gig SAS benefits this tier is the dynamic scaling up to 64K devices, support for high performance SAS hard drives as part of the scaling model, and the reliability for multipath failover with including RAID. So in the next tier, we have the cold deployment, the cold tier. This you'll see more of a focus on hard drive deployment. The server may still be SSD based, but if the performance is not required, it may be hard drive based. It's depending on the flavor of the deployment that is required by the integrators. So you'll have a typical cascade of JBODs that'll include SAS expanders and the JBODs, and for the lowest cost deployment, SATA SMR hard drives. There's also SAS SMR hard drives, but if you're going for the ultimate lowest cost, lowest power implementation, SATA SMR drives will be the deployment model here, where you're striping and streamlining the data kind of more in a backup archive method, similar to the tape deployments in the past. The deployment here is to support the offloading of active data, so that it becomes more of a read-only segment or storage of the data. And you'll typically see this in data center applications such as social media, so a crossover from the warm tier. This is the streams or the posts that are being constantly put out there but not being accessed as often. Those are going to be relegated to more of a cold storage, so that someone can still pull up something from a week ago or so, for example, and it can be read from an archive area in this cold tier. Cloud storage absolutely fits this model, where you'll have whether your personal or business data is storing data into the cloud, whether it's backup or not as oftenly accessed data. You'll want to put that in a cloud storage area, and you'll have many reads but fewer writes. That's where this type of topology will come into play, as well as the Internet of Things area, where you're storing data that's maybe already been processed, but you want to have it available for later access. That's the Internet of Things deployment in this cold tier. So ultimately, the storage requirements for this deployment is large scale, so you can deploy as much capacity as you can to support the needs. Focus on low power, low cost, low ownership costs, total cost of ownership, as well as providing the highest capacity at the lowest price per gigabyte. This is where the hard drive technology comes into play and suits the SAS topologies of today very well. So where 24 gig SAS benefits this tier is, again, the flexibility to support SATA hard drives in a SAS ecosystem and architecture. And again, the dynamic scaling up to 64K devices, but also having the rack level and data center level reach as you span out your large scale. So here we have the data center storage applications that span a spectrum of performance, and whether it's read or write intensive. So at the x-axis, you'll see the scale from the left to the right, low performance to high performance. And on the y-axis, you'll see the lower scale being read intensive up to write intensive. So the application bubbles are meant to represent general range across these different axis areas, with the larger bubbles representing a wider range requiring reads and writes, as well as performance demands. So the different types of examples we have shown here may not include everything, but it's an example, and these are all different areas where SAS technology may be deployed or is already being deployed. From the highest level of, in this example, of being financial trading, where you need very high performance access, a lot of write intensive access. Some examples of this area would be Robinhood, Webull, which are the personal trading apps where you get folks logging into those, making their trading requests, buying and selling, putting options out there. Now, in the middle of this whole dynamic scale here, you have AI, where you'll have Palantir as an example, where you'll have big data analytics, business and government situational awareness, decision analysis, where you need to process data that you're capturing, surveillance tools, a lot of applications that need to be capturing data and then processing it afterwards. So you'll have a mixture of performance and read and write access. And then all the way down to the lowest left corner, where you have cloud storage, as I mentioned previously, where you You'll have more archival implementation. So you'll have lower performance typically, but it'd be more read intensive on the scale of things. As an example of one of the areas to fit into the map here for AI and business analytics, if some of you may recall some information not too long ago about the Event Horizon Telescope project, where we collected 4.5 petabytes of data over a number of days, mapping a photo of a black hole. And this was based on WD 8 terabyte hard drives, nearline hard drives that were used because the SSD cost to capacity limitations, and the hard drive was the best solution there from a cost per gigabyte standpoint and implementation. Some other examples here that everyone are familiar with are content delivery, where you'll have Netflix, Hulu, Disney Plus, Amazon Prime. Those are all areas that are very active in the market today, and that's more of a middle of the road type of performance requirement, more read intensive, because you have the content sitting out there with lots of users trying to access that data, downloading that data, streaming that data. And then IoT is a pretty broad area where you're going to have Samsung Smart Things, Alexa, video doorbells, thermostats, light switches, surveillance systems, lots of home automation applications fit into this IoT area that are exploding. As a matter of fact, back in 2018, it was estimated that there were 7 billion devices connected to the internet, and 41.6 billion connected IoT devices going forward and out to 2025, generating a total of the expected 79.4 zettabytes of data. And this is based on an IDC report back in June of 2019. So it gives you a picture of how things are just exploding out there, drives the need for SAS and SATA storage in a SAS architecture. And some last areas to mention here: social media, very prominent. Lots of folks accessing Facebook, Instagram, YouTube, Twitter, LinkedIn, TikTok. There's tons of data being stored in video format, picture format, and it's ever increasing demand on this storage infrastructure. And with COVID over the last 18 months, there was an increase of data use in the data center and hyperscale as more people did a work from home, lots of meetings, lots of virtual conferences happening, as well as kids doing at-home learning in a lot of cases. So there's a lot of data-driven access going on over the last year or two. So basically, data everywhere and every way. It's prominent, and SAS is there for it. So just to give an overview of an example on social media implementation, here is an example where you'll have a social media interface that has a navigation and a community where you access the different levels, different areas of the site, whether it's in app form or web page form. You'll also have stories or updates from your friends or things you're subscribed to, news feeds. You'll have implemented ads and promotions and different ways of chatting or video chatting, interfacing with those friends and different groups on this system. So how this relegates into a tiering model is, I have some areas highlighted in yellow, some area in red, area in blue. These associate to red being a hot, yellow being a warm, blue being cold. So as we go forward and look at the breakdown into the different tiers, you'll typically have a OS and web server. That's the main interface. That's typically just a mirrored boot volume where your performance is not necessarily high, storage capacity is not necessarily high. It gets deployed into different tiers. You'll have a warm tier that's a database for your user data, and you'll have a SAS hard drive or SSD implementation with RAID, where you're servicing a medium capacity point, but more of a high IOP access, so that users can get to and from their data more on a readily basis. And then for the things that are not being accessed as readily or are becoming stale but don't want to be lost, things get pushed into an object store where you have more of a cold storage, a backup of that information. And this will typically be implemented in a SATA hard drive deployment cold tier. And this is where you'll have higher capacity but lower performance, kind of a backup area. And then the interface that does the caching for all this access to the data, as well as capturing user data, analyzing user data, will have a hot tier where you'll be based on a couple of SSDs, lots of RAM, memory, where you'll have low capacity requirements, but high operations per second requirements, so you can monitor the data and reallocate the access points of depending on the user going into the system. And then what does this translate to from an analytics standpoint? So all the information that you're using in these systems based on locations and demographics, user profile, friends, likes, groups, etc. This is going to be information that is being monetized by the platform typically, and they'll capture all this data and feed it back as an ads page. So that's going to be in a hot processing tier that gets relegated or sent back to you on your interface as a warm tier. And as an example, one server per 2,000 users, if that was the implementation, 2 billion users would require a stamp and repeat of this system 1 million times. So more and more storage deployment to support ever-growing user bases in the social media spaces. So another area that's becoming an increasing storage deployment is cryptocurrency. So storage-based cryptocurrency, one example is Chia. This is a recent example. So this is an implementation of proof of space and time. So it's, everybody's familiar with Bitcoin. Bitcoin is based on a proof of work model where miners perform complex operations, computations to verify transactions. This is based on Bitcoin, the decentralization like Bitcoin, but the implementation is using proof of space and time, which is using storage capacity. So instead of mining, there is a two-stage process of plotting and farming. And this is a deployment as shown on the right that's going to be based on a hot and warm tier type of deployment where you'll have a hot tier that's going to be a server that's based on SSDs, so you can do the processing of the data. For example, in the plotting portion of the implementation, you'll be creating plot files and hash tables for the indexing that's pointing out to the large farm of hard drives so that the data can be retrieved quickly, and that is the proof of valid or not as the Chia implementation. So some might recall this was launched back in May of 2021, and this deployment, before that even reached that milestone, was showing shortages or creating shortages in the storage market as all these implementers were seeking the nearline storage in the market. So this is a vast area of data storage, and that just kicked off back in May. Where we're at here in August, there are currently 35 exabytes in net space on the Chia network, as an example. So vastly growing area, a lot of future use, and not to mention if there's any other implementations of cryptocurrencies that are based on similar methods, you'll see a stamp and repeat type of method. So the plotting method, it's very write intensive. So you'll need some SSDs for processing some of that data. But the farming is where the bulk of the storage is deployed, where you need to store as much as you can with the lowest power per cost possible using nearline hard drives. And that's the topology shown at the right. So a very relevant recent use case. All right, so where does this, what does this mean for the technologies that are being deployed? So just to do a quick overview, where SAS intersects with new media innovations to support these Turing models. You have a bunch of different technologies coming to market, making headlines. You have QLC NAND, even PLC NAND. These are being implemented in more capacity-oriented SSDs, together with storage intelligence and multi-link SAS connections that allow for more bandwidth per SSD. These are all areas where the SAS standards have adopted to these continually innovating areas in the market. And on the hard drive side, it's the same story. We have multi-actuator, we have SMR, and MAMR, HAMR. These are all towards capacity or increased IOPS per capacity metrics that are all being implemented, integrated into the SAS standards. So we're, as storage media is ever changing to increase these IOPS and capacity, we in the SAS and SAS standards are adopting these different methods as part of the main way to deploy these different tiering storage models. So where is 24 gig SAS now? It's here. We have SAS 4 systems and products now shipping and larger ramping going into 2022, with protocol analyzers having been shipping for the last year and more. Cables and connectors are available with existing and new form factors. So the newer form factors that were previously highlighted were the mini link and the slim SAS, so different types of high density connectors. Some of them more existing connector form factors were the mini SAS HD, which you can implement as copper or optical for more reach. So these are all the interconnect required for 24 gig SAS. You have your controllers and expanders aligned with new PCIe Gen 4 servers that are now coming to market from multiple ecosystem and platform vendors. So a number of announcements have been made over the last 6 months, maybe a little bit more, with products becoming available, coming to market in production or being introduced. And not to be left behind, but the other area that completes the ecosystem is the storage, and that's the new hard drives and SSDs. The SSDs are adopting 24 gig SAS for a native interconnect, and there's been some announcements there. But the hard drives with the different technologies to support expanded capacity capabilities with multi-actuator and SMR, for example, these are all coming together at a time that the 24 gig SAS ecosystem will support these. So as another milestone, there's a 24 gig SAS Plugfest that is underway now, and this is the way the industry shows its wide support for end-to-end products. It verifies the specification interpretation across the vendors and determine if there's further spec enhancements to be considered. The products that are shipping today have been probably tested more in discrete environments, but with a Plugfest, it gives a more broader adoption filling certification that the product will work with all these different types of integrated interconnections, and easier for integrators and designers to get the general market. So the success of this Plugfest will make everyone more comfortable with their deployment going forward. And this is what's happening now. Our second 24 gig SAS Plugfest that'll be concluding here shortly in the upcoming weeks. So to wrap things up, I'd like to give you a couple of key takeaways. If for those that are familiar with SAS, this overview is probably not as unfamiliar to you, but the SAS architecture is optimized for scalable and flexible deployments. And I reviewed the different tiers and their target applications, whether you have a hot or a medium or cold tier, to support the different requirements of IoT or data analytics, financial, different areas that require very high performance to more that are capacity oriented, not as much as performance in a online cloud storage implementation. There's a wide span of areas where SAS and SATA is deployed. And with the COVID pandemic, it's accelerated the need for storage infrastructure at all levels: work from home, virtual conferences, and at-home learning. So overall, SAS is not going anywhere anymore. It's addressing the accelerating demand for storage. It continues to adopt the latest innovations in media technologies for increased capacity, cost, and performance metrics, as well as working together with some NVMe deployments in some ways. There's some U.3 definitions. It's being called U.3, but this is an area where you'll see NVMe and SAS working together in certain applications that becomes important as we both increase our market share and deployment models. So I also mentioned in the previous slide the available 24 gig SAS products and things that are coming to the market: analyzers, exercisers, RAID adapters, SSDs, connectors, and cables are all important aspects of the end-to-end architecture, and more announcements and devices are expected to come in the next several quarters. So that concludes my webinar conversation here today. And just a reminder, there will be a future blog post to answer any and all questions that are submitted here today. But at this time, we'll switch over to any questions that we've received so far to conclude out our discussion here today. Okay, let's see here. We got a couple of questions. Do you think the adoption of 24 gig SAS is linked with the rollout of PCI Gen 5 and bandwidth balancing? So the adoption of 24 gig SAS, I guess to answer that question directly, yes, that's one area. It's more aligned with the PCI Gen 4 platforms with the capability of 24 gig SAS designed to match and exceed PCI Gen 4 interfaces for host cards today. That's the beginning of the deployment for 24 gig SAS, but I think we'll see increasing growth for 24 gig SAS going into Gen 5 platforms as they are quickly following up behind the Gen 4 platforms. So for bandwidth balancing, certainly, I think it'll help to continue the saturation, because with a fully loaded 24 gig SAS, you can saturate the Gen 4 PCIe interface. So Gen 5 interface will allow for more room for expansion, and we'll see what the future holds for there. And you can expand your lane widths on your 24 gig SAS interconnects as well to come to more saturation on even that technology. So very well suited for Gen 4 and even more so for Gen 5, certainly. Let's see, next question. Do you expect hard drive capacity to continue to increase? Will hard drives continue to be cheaper than NAND SSD cost per capacity? So yes, the hard drive capacity is expected to increase, right? And you can see the deployment of the capacity is expected and projected by IDC to increase quite consistently over the coming years. There's just the deployment model is pretty straightforward, well understood. There's advancements happening in different areas to increase the terabits per inch. So yeah, we'll continue to see that capacity increase. As far as when will hard drives continue to be cheaper than NAND SSDs? There's probably a balance to this question. So there's some NAND out there that can be cheaper than some of the hard drive deployments. Like high performance hard drives are easily replaced by SSDs of an equivalent capacity and even bigger capacities in those areas. But to get an equivalent cost between a cold storage focused hard drive and NAND, it's going to be a challenge to meet the scale of deployment, because you have so much more capacity that's being shipped and available in the hard drive market space today that the NAND will have a lot of work to get up to the same deployment level of NAND capacity. So at some point, we'll probably see a crossover, but in the near future, hard drives are continuing to be the go-to model for capacity deployment. Okay, let's see here. Can we mix 24 gig SAS hard drives and 24 gig SAS SSDs? How does the host handle the difference in read-write performance when there are two different classes of media attached? So yes, so there are some standards enhancements for fairness that are built into the more recent standards. So one of the dynamics that was seen in previous deployments, going from 6 gig to 12 gig, which is an area where SSDs just started showing up to the market, you do see some differences in how the interfaces handle SSD access versus hard drive access. SSDs can respond and do data transfers a lot more quickly than hard drives in those cases. So sometimes that would become the preferred channel. While going into 24 gig SAS, there's more balancing metrics put into place so that you can get an even mixture of 24 gig SAS, 24 gig hard drives, 24 gig SAS SSDs, and um, you can even assign prioritization or methods of keeping the data access in the areas, in the storage elements that you want to have the most performance. So today, there are only 24 gig SAS SSDs in the market. The hard drives are at 12 gig, 12 gigabit per second SAS. So you will see more of an imbalance as a 24 gig SAS SSDs will be a lot more faster to respond to the link. And it will require some balancing in some ways. So overall, you can mix them, and there are now new metrics or new abilities in place to keep all the access fair across the topology. Let's see, we have a few more minutes here. So for cold tier, what is the max number of hard drives, SAS or SATA, that I can connect? So, the SAS standard supports 64K connected devices. In most deployments today, you'll see different deployments. You'll see many deployments that have a parallel deployment model for a lot of the drives that are connected to the same architecture. So you can certainly have thousands of hard drives, but in a lot of ways, you'll start reaching areas where the performance balancing is better if you span it out across a tree structure, so that you can have load balancing through a switch, for example. You can do zoning. That's probably your ultimate implementation when you're deploying a bunch of hard drives. But technically, the standard can support up to 64K devices attached, SAS or SATA. And the deployment model will vary based on different vendors and integrators' data center designs. Okay, looks like we have one more question here. When do you foresee NVMe overtaking SAS? Kind of a loaded question, but as you can see, maybe I can go back to the IDC data slide here. So with the projections that are currently in place, I mean, there's been vast expectations for NVMe growth, and NVMe has certainly been reaching those expectations and exceeding them in a lot of ways. But the sheer amount of capacity that's being deployed with hard drives that are based on SAS architecture is a number of times greater. So if the trend continues, there may never be a crossover, but we can't really predict the future. But there is a lot of parallel growth happening with U.3 being a defined SFF type of deployment, where you can have NVMe or SAS or SATA connected within a server environment, a common backplane. You might see a parallel deployment of these technologies. So there might be more NVMe SSDs going forward, more NVMe SSDs versus SAS and SATA SSDs for sure. As SAS tends to have a lot of hard drives based on SAS and SATA architecture, with maybe a little bit of SAS and SATA SSDs for caching tiers. There might be a crossover, but for the foreseeable future, we don't really see where NVMe will overtake SAS. They're both growing at pretty substantial rates at this time. So it could be 5 or 10 years further beyond what's being projected here. before we can really see what if some kind of crossover will happen. Okay, so that's the end of our allocated time for today. Thank you everybody for attending this webinar on the 24 gig SAS deployments with tiered storage. Don't forget to visit the SCSI Trade Association's website, scsiTA.org. We hope to see more of you in the future and look forward to more talks and webinars from the SCSI Trade Association. Thank you.